How do you measure and compare the sizes of earthquakes? The size cannot be judged solely by the damage to buildings or the number of people killed. That's because a medium earthquake close to a large city will cause more destruction than will a larger earthquake in an unpopulated area. Seismographs are the instruments that scientists use to measure earthquake shocks. Modern seismographs record their data to a computer and are able to detect a tiny earth tremor thousands of miles away. Seismologist G4U2 of Germany's Geoscientific Research Institute points to the shock waves that were recorded in blue in this digital graph, right, of the March 28, 2005 earthquake off the island of Sumatra. There are hundreds of seismographic stations all over the world that time the arrival of earthquake waves. Scientists use the measurements to find an earthquake's timing, magnitude, and location, latitude, longitude, and depth. Scientists use the Richter scale to measure an earthquake's magnitude, the amount of energy it releases. Each number on the Richter scale stands for an earthquake that is 10 times more powerful than the number below it. You would hardly notice a magnitude 2 earthquake, but a magnitude 3 earthquake is 10 times greater and easily felt by everyone. The scale has no upper end, but any earthquake that registers 6 or more is considered a major earthquake. The earthquake off the island of Sumatra on December 26, 2004, registered a 9.0 magnitude and caused huge earthquake-formed sea waves called tsunamis. The enormous earthquake and tsunami waves killed more than 200,000 people and caused immense destruction in several countries. Scientists use observations as well as instruments to measure the effects of an earthquake. The Mercalli intensity scale uses observations of the earthquake damage to rate it on a scale ranging from 1, where the effects are scarcely noticeable, to 12, where damage is total and the ground heaves in waves. Usually, the intensity is greatest near the center of the earthquake and smaller farther away from the center. But other factors, such as the soil in the area and the construction of the buildings, are also important. For example, the earthquake that shook the San Francisco area in October 1989 during the World Series measured 7.1 on the Richter scale. On the Mercalli scale, it measured 10 to 11 in the Marina District, shown here, where the houses are built on loose soil, but only 6 or 7 in other parts of the city, where the houses suffered much less damage. Sand, mud, and water sometimes bubble up during earthquakes, gushing water and soil like miniature mud volcanoes. These sand boils are particularly dangerous to buildings. In places where water is close to the surface, sandy layers turn into quicksand and buildings tilt and crumble. During the 1989 San Francisco earthquake, sand boils erupted in basements and yards and beneath houses all over the Marina District. These apartment houses in Niigata, Japan, tilted and tumbled as a result of an earthquake in 1964. The buildings tilted when the soil beneath the foundations turned to quicksand. About a third of the city sank by as much as 6 feet. On the afternoon of Good Friday, March 27, 1964, Anchorage, Alaska, was shaken apart by the most violent earthquake ever recorded in the United States. It measured 8.4 on the Richter scale. Government Hill Elementary School was split in two when the ground beneath it dropped. Houses began sliding apart. Giant cracks opened in the pavement, and the ground rolled in huge waves. In the first 3 days after the earthquake, 300 aftershocks shook the buildings that remained standing. The Good Friday earthquake brought another type of destruction along the coastline. The focus of the earthquake was deep beneath the waters of Prince William Sound in the Gulf of Alaska. The earthquake acted like a giant paddle, churning the waters. Tsunamis battered the land for hours. An entire section of the waterfront at the port of Seward cracked off and slid into the ocean. Boats were overturned, buildings broke apart, and everything was left in a tangled mess. The tsunamis moved across the Pacific at speeds of hundreds of miles an hour, reaching as far as Hawaii and even Japan, 4,000 miles away. Scientists have learned much about earthquakes and their effects. They can measure even the slightest movements along faults. But we need to know much more about earthquakes before we can predict weeks or even days in advance when a big one will hit. Until then, proper building design can help lessen their effects. We now know that houses in earthquake-prone areas should be built on solid rock and not on sand, for example. In California and Japan, new houses are designed to be earthquake resistant. It also helps to know what to do when an earthquake strikes. If you are indoors, get under a heavy table, desk, or bed. Stay away from windows, mirrors, or high cabinets. If you are in a high building, stay out of the elevators and stairways. If you are outdoors, move away from high buildings, walls, power poles, or any other tall objects. If possible, move to an open area. Above all, remain calm and don't worry. The chances of your being hurt in an earthquake are very, very slight.